Welcome back to part 2 of chapter 1. So we're on chapter 1, section 2, elements, compounds, and the periodic table. So we talked a little bit about the periodic table last time. We said that's where you find those elements that are pure substances. And that is all the elements that are on the earth, the periodic table. And if you look at the periodic table, you see a bunch of different little squares, right? And each of those little different squares or blocks holds a different element. And the letters inside are the abbreviations for the elements, and then we have some numbers, and we're going to talk about what those numbers are. But the letters inside of it are the chemical symbol. Like we said, remember last time we were talking about AU? Well, AU is gold. So AU is the chemical symbol for the element. Now that's a little like why AU, but it wasn't in English, so that's why we have a different symbol. But things like, let's say, right, hydrogen, that makes sense. We have it as an H, right? So for most of the elements are very, very easy. They're derived from the English. Some of them are not. Some of them are actually Latin. And so that's where we get the AU for gold, the Na for sodium. So there are a few that you have to kind of learn, but not too many that are that strange. So here's our periodic table, right? And you need to be familiar with how to find things on the periodic table and what they mean and things like that. So the first things that we need to talk about are period numbers and our group numbers. So periods go across. So here's I'm going to circle everything in period 1. Ooh, we only have 2 elements in period 1. Now, if we go down to, let's say, period 3, here are all of the elements that are in period 3. So periods go across. Groups, on the other hand, ooh, let me go back. Let me clear that. Okay, now groups go from top to bottom. Groups are a column. So here's group 1A. If we go down, let's see, let's do group 3A. Oh, and notice that you have groups that are either A's or groups that are B's. So we're going to talk about why that is and how we use that in terminology. So a vertical column is a group. And when we look at a group, we can see everything in group 1. These are going to have common properties. So all of those are going to have very similar properties, except for hydrogen. Hydrogen is kind of weird. But the rest of them are alkali metals. So they all behave like alkali metals. Group 2, alkaline earth metals. They're still metals, but they behave a little bit different. Then we have our transition metals, right? All these are transition metals. And then as we move down the periodic table, we're getting some different properties, right? Look at the very end. Look at our group 8A. These are noble gases. So all of these that are in this column or this group all behave very similarly. That's why we give them a common name, like noble gases. So every group has a number and a letter designation. A is for main group elements. B is for transition elements. So I'm still learning to use this, y'all. Okay, so if you're in A, you're a main group. So see the designation up here, main group elements. We have alkali metals, alkaline earth metals, and then we pick up way over here with the rest of the main group elements. Now you also have transition elements. So here are transition elements, and here are also transition. These are inner transition metals. So main group are in red, and then transition are in orange. So there are 2 different ways that we number those columns. You could use a 1 through 18 numbering system, which is pretty straightforward, right? 1, 2, it's the ones in parentheses, 3, 4, so on and so on and so on, until you get to 12, and then 13, 14. That's one way to do it. But the really standardized way to do it, the IUPAC, the International Union of Pure and Applied Chemistry, we use we use the 1 through 18, but what you're going to see is sometimes you're going to see it as A's and B's. And so you have to be able to do either one. When you're looking at them, you go 1, 2, 3, 4, 5, that's nice and easy, but be careful when you're saying 1A, 2A, and then if you stay in the A's, you got to jump all the way across all of these transition metals and go to 3A. So be careful with that because 3A is very different than 3B. So just kind of pay attention and know how to do either way. All right, a horizontal row. So if we're going across this way, that's a period. Periods are 1 through 7. There's only one way to number them, thank goodness, right? The periods 6 and 7 are at the bottom of the periodic table. So if we go back, let me clear this. Right? So here are our period numbers. Okay, and then these two right here, we still have periods 6 and 7, right? Okay, so the next thing that you should see is a staircase shaped line. And this is what we use to visually represent the separation between metals and nonmetals. So if we back up and we say, okay, here's our stair-step line. Here we go, it starts here. And see how it goes every other? That's our stair-step line. And so here we're separating the blues are metal and metalloids. And well, just say metals. And then these yellows are non-metals. The greens are the metalloids. So they're kind of halfway in between. They're not non-metals, they're not metals. But it's that staircase line that separates the metals from the non-metals. Okay. So elements that border the line, except for aluminum, are metalloids. So if you go back and you see they're all the ones surrounding that line are metalloids except for aluminum. Aluminum itself is actually a metal. Okay. So when we talk about elements, what elements are really important for healthcare? Well, there are some that are really essential for human health, and we need them inside of our bodies in huge quantities. Carbon is the number one. Well, you're really about 70% water, so oxygen and hydrogen are super, super, super important. But if you took our dry body weight, so our entire body mass that had no water, what you would see the most of is carbon. You see more carbon inside of your body than you would percentage-wise in the Earth's crust, like what makes up all of the Earth. You have 100 times more carbon in you than in the Earth itself, which is kind of cool. That's why we call us carbon-based life forms. That's where the little term comes from. So the ones that are in the highest quantity are carbon, hydrogen, oxygen, and nitrogen. And those make up the majority of our biological molecules. They call them CHON, C-H-O-N. That's a little way to remember it. So those are our essential, right? These are the most populous inside the body. The next group are called macronutrients. Macronutrients, you need them, not as much, but you do need them. It's about 100 milligrams per day of each of these that you need. Sodium, magnesium, potassium, calcium, chlorine, they're involved in signaling, they're involved in bone growth, right? All this kind of stuff that you need in relatively large quantities. Then you have micronutrients. Micronutrients are needed, but you don't need a whole lot of them. Iodine is one of them. You need a little bit, but not too much. Fluorine, iron. Iron, think about in your blood, in your red blood cells, you have hemoglobin that binds to the iron. And so that's what allows your red blood cells to carry oxygen, because that iron likes oxygen. And that's how you transport oxygen all over your body. So here's a little graphical representation, right? Our most common elements of living things, C-H-O-N, CHON, those are our top 4. Then we have our macronutrients, right? And you can see some of them are metals, some of them are non-metals. And then you have macronutrients, and the same thing goes. We have a mixture of metals and nonmetals. So when we look at all of this on the periodic table, right, we've talked about what a pure substance is. A pure substance is two or more chemically combined elements. And it can be, a pure substance can be one of two things. It can really be just an element, or it can be a compound. When we talk about a compound, that's where we have two or more elements. So like H2O versus O2. O2 is an element, H2O is a compound. So compounds will combine in specific ratios. Always. Anytime you look for water, what you're going to find is a substance that has 2 hydrogen atoms and 1 oxygen atom. Always. Table salt is another example of that. Water is a covalent molecule, right? So you're going to look like a hydrogen, another hydrogen, and an oxygen. You'll have covalent bonds that attach that hydrogen to the oxygen. Sodium chloride is a little bit different. It's an ionic compound, and so basically what you have is a sodium atom and a chlorine atom, a sodium atom and a chlorine atom, a sodium atom and a chlorine atom, chlorine atom and a sodium, chlorine, sodium, chlorine, sodium. But the point is that you have a 1-to-1 ratio of sodium to chlorine. So really it is Na1Cl1. If there's nothing written there, we assume it's a 1, we just don't write it. So the correct way to write that is just NaCl. That's why when we say H2O, what we really mean is 2 hydrogens and 1 oxygen. We don't write it like this, H2O1. The 1 is understood, so we don't write it. We write it this way. So our chemical formula tells us what elements are there, and then the ratio of the atoms in each compound. And so they give us actually a lot of information. Okay, so here are our practice problems for section 2. So we want to classify each of the following as an element or a compound, and we're going to explain our classification. Aluminum, used in soft drink cans and foil. Aluminum, where do we find aluminum? Aluminum is Al on the periodic table, so that must be an element. Right? Sodium hypochlorite. Sodium hypochlorite is actually something that's found in bleach. So sodium is Na, and hypochlorite, you don't have to be able to write the formulas yet, but what you should notice is you have sodium, that's an element, and then you have some other stuff. And so that's not just one element, that's going to be more than one element. And so this is going to be a compound, right? This compound, because we have more than one element. Whereas aluminum was one element from, I don't have room, so I'm just going to put PT, periodic table, not physical therapy, periodic table. All right, hydrogen, fuel of the sun. Hydrogen, it's actually going to be H2, but still it's one element, so this is an element. It's found on the periodic table, right? One element. Potassium, potassium is going to be K. Chloride is Cl, so KCl. It's a table salt substitute. Well, we got 2 elements, so this must be a compound, right? It was more than one element. Same rationale as above, more than one element. All right, let's see. Use the periodic tables to supply the missing information in the following chart. Everything's on the periodic table except for this part, right? You kind of have to get familiar and try them out. So fluorine. Fluorine is an F. So if you go to the periodic table, we need the group, the period, and is it a metal or a non-metal? Okay, so you got to find F. Here's fluorine. We want to know the group. So in fluorine, we're in group, and you could list it as the IUPAC or the AB. Doesn't matter to me. So you could do 7A or 17, either one. And then what are we, a metal, a non-metal, or I think they asked you just metal or non-metal. They're only going to give you metal, excuse me, or non-metal. So all these yellow ones are non-metals, right? So let's go and fill in our table. So what did we say? Fluorine was in group 17. Oh, they're doing the A. So 7A, and I'll put in parentheses 17, right? And we were in period. Oh, we didn't talk about that. What period are we in? So if we go across, what period is fluorine in? It is in period 2, right? Okay, so that's period 2, and we said it was a non-metal. M-E. There we go. Okay. So our next one, we're not given a formula, not given a symbol or a name. So we have to go and look it up. So we need to go find group 1A in period 2. So let's go up. Let's do a different color. So we're going to do group 1A. Here is group 1A, and we're going to be again in period 2. So you just kind of have to make them meet. And what do we end up at? We end up at lithium. So Li. So we're going to come down and we're going to say this is lithium. And then the question is it a metal or is it a non-metal? So if we come up here, all of these things that are in blue, all of that stuff is a metal. So this is, whoa, this is a metal. There we go. Okay, chlorine, Cl. I guess I should do a different color so we don't get all confused. Chlorine, Cl is chlorine. So we got to go look it up. So let's go find chlorine. Here we go right here. Here is chlorine. So we need to know the group, the period, and is it a metal or a non-metal? So we're going to look up here and we're going to see that it is group 7A or group 17. And then we're going to go across this way and we're going to see that it is in period 3. So let's go write that down. Oh, and the last one, it is yellow. So it is a non-metal. So to come down here, chlorine is 7A or group 17. We said it was in period 3 and we said it was yellow, so it is a non-metal. Okay, the next one, we're given the group and we're given the period. We need to figure out what element it is. They're telling us that it's a non-metal, so you at least kind of know that you should be looking in those yellow elements. But 4A, group 4A, period 2. So let's go. Group 4A in period 2. So we're going to go down and across. So here we go. And we meet right there at carbon. So carbon is a C, and that is carbon. Okay, pretty easy. You just got to know what you're looking for. All right. 19, identify and give the number of atoms of each element in the following compounds. All right, lithium carbonate, LiCO3. So you got to remember what these little subscripts mean. These little subscripts are telling us the number of atoms. And if you don't see anything, you can assume it's a 1. So we have lithium, and lithium, we don't have a subscript, so that's going to be a 1. Carbon, we don't have a subscript, so that's going to be a 1. Oxygen, on the other hand, we do, it's a subscript of 3. So this is 1 lithium atom, 1 carbon atom, and 3 oxygen atoms. Okay, that's what the numbers mean. They mean number of atoms. All right, let's do B, H2O2, hydrogen peroxide, a disinfectant. So what that's telling me is for hydrogen, I have 2 atoms. For oxygen, I have 2 atoms. And if you want to write out the name instead of the abbreviation, that's totally fine too. So C8H8O3, vanillin. This is the flavor compound in vanilla beans. So the carbon, a subscript of 8, that's telling me I have 8 atoms. Hydrogen, that's telling me I have 8 atoms. And then oxygen, I have 3 atoms. Okay, so you just look at those subscripts, and those subscripts are going to tell you exactly how many of each you have. All right, and that is our end for section 2.